Hello, I'm Amber Lutman, and this is Wednesday afternoon Group A. And so today we are aligning our heating laser. So first we started by putting the laser on a stage that allows it to move back and forth and also has tip tilt adjustment as well as height. And then we placed two pinholes at approximately 200 millimeters off the rail. And then we started with two to allow us to align the beam roughly with just the two. And then we removed one of the pinholes, and using this pinhole, sliding it back and forth, we checked our alignment and made any final adjustments, and you can see that the beam is coming through no matter where the pinhole is placed, so it's aligned.
My name is Josh Brandt. This is continuing Lab 1. So this is where we're using the pentaprism and water to check if the table is balanced, is level with gravity. So the pentaprism marks down to the water, reflects off the surface, and goes back to the laser. And the reflection is right there. You can see as the table moves, it moves slightly. And it's not perfect, but it's pretty close considering all the reflections.
I'm Thomas Myers, continuing on with the next section of our lab. We have a beam splitter placed here and orthogonal optical rails in order to get two beams 90 degrees from each other. So you can see as Josh moves this back that our beam stays through the iris the entire time, indicating that it is 90 degrees to this same rail we used last time.
In the next section of the lab, we're aligning different lenses to the laser. So here we have a 1,000 millimeter focal length lens, and we have it on a stage that moves both in X and Y and has tip tilt to have all the degrees of freedom covered. And when we aligned it so that all the beam reflected back goes into the opening of the laser, and you can see that both the first reflection and the back surface reflection are aligned with the laser.
So we continued with aligning lenses with our laser. This time we used a 100 millimeter biconvex lens, and you can see that all the back reflections have been aligned directly into the laser.
So again, we were aligning a lens. This time it was a 50 millimeter plano concave. And again, we looked at the reflections and aligned them so that they go back into the laser source. Okay, so we made a telescope. We started with the 50 millimeter negative lens up close, adjusted it so that the reflections went into it, and then slid it back. Then we put in the 1,000 millimeter and adjusted it so all the reflections go back into it so that it's along the same optical axis. And then we aligned it so that they're 950 millimeters apart, so that it makes the telescope. And then there's the image down there.
In this next part of the lab, we co-aligned two beams in space. So we have our original Heaney red laser, and we have this green laser next to it. In order to make sure that they were at the same height and both aligned parallel to each other, we used the pinhole that's over here now that we used before for the red laser, placed it on the green laser's rail, moved it back and forth, and aligned the beams. And since this pinhole was at the correct height for this beam, we knew that this beam would also be at the correct height. Next, we took a pentaprism and placed it on the green beam's rail. Theoretically, this should bend it 90 degrees perfectly, but because of the different tip and tilt of the stage, we had to do some minor adjustments. And so we placed another rail here so that we could make sure that the beam coming out of the pentaprism was 90 degrees to the original rail using our same pinhole. Finally, we placed our beam splitter in the path of the red laser and the bent path of the green laser, and doing adjustments to both rotation and tip and tilt of this, once again using the pinhole and the wall. You can see that we have co-alignment the two beams, and so it appears sort of yellowish, and we know that our alignment is solid because behind me you can also see the other beam exiting, which is also the two beams are co-aligned. Pause.
Alright, so to start the final portion of our lab, we had to align a microscope with the optical with our laser. So on this piece of paper over here, we drew a mark where where our laser hit the paper when there was nothing on the optical rail, and then we put in the microscope and aligned it with our laser such that the center of the spot from our microscope would match up with that same dot we drew initially.
In this final part of the lab, we placed a lens in front of our microscope and made sure that at first when we placed the lens in there, the spot was no longer aligned with the crosshairs. But after realigning the lens to both the laser and the microscope, as the lens is moved, the spot changes in size because of changes in the system, but that's okay. But overall it stays in the same position, showing that all three items are aligned.